In this video, I'm going to walk through some initial explorations I've done in order to better understand how sequence packing and flash attention work. I'm very unfamiliar with the actual implementations of sequence packing and flash attention, so this exercise really helped me understand some high-level concepts. So the first thing I want to mention is that you need a flash attention 2 compatible GPU, so I'm using the L4 on Google Colab. The next thing I did was that I forked the transformers library and added some print statements in some key locations where it would help me understand what values that I passed in to the model's forward pass were actually being used and what values were not, and how was that impacting how flash attention was being called for either sequence packed inputs or regular padded batch inputs. So Colab has transformers, so you have to uninstall it, and then I installed my repo that I forked. I'm using the small LM2 135 million parameter model, and I'm specifying flash attention 2 as the attention implementation just to make sure that it does kick in. In a different notebook, I used the inspect library, and inspect library has a get source method, and so you can pass it a forward pass or you can pass it a function and it'll show the source of that in the notebook. So that was kind of like my version 0 exploration to understand when I pass the inputs to the model's forward pass, like where does it actually go and what are the names of the different functions that are called, and that's what helped me identify the 2 or 3 key functions that I needed to inspect and add print statements to in the transformers library. So those 2 spots are in 2 locations. So first in transformers integration flash attention.py, this is called from within the self-attention forward pass in the layers. This is the file in my fork, and let me zoom in a bit, and I'll zoom in a bit here. So inside flashattention.py, there's a flash attention forward, which is the only method that's defined in there. And first thing I did was I added these 2 print statements to, number 1, make sure that this is actually being called when I give the model some inputs. And then 2, I wanted to see what are the keyword arguments that are being printed. So that's the first file I modified. The second file is flash attention forward with an underscore, and if we look at flash attention forward without an underscore, the version is being called from inside there. And that underscore version lives in transformers, source transformers, modeling flash attention utils.py, and here it is. And inside here there were a couple of things. I did the same thing. I wanted to see the keyword arguments. I wanted to see if there was an attention mask being passed, and I wanted to see if there was position IDs being passed, so those are some initial things. Then if I scroll down here, I wanted to see, like, is attention mask not none, or is attention mask none, and if not, I wanted to see that is this being called. And then scrolling down, if position IDs is not none and this condition is true, then it would call this print statement that I inserted, and then if Q, seq lens, Q, and K is none, then it would call these 2, and then it would call prepare FA2 from position IDs, and then it would print out Q, seq lens if that was, if all this was being called. So initially, my initial kind of goal, let me make sure there's nothing else. Yeah, so the initial goal was I wanted to understand how this Q-seq lens is utilized, because that was something that came up in my conversation with Claude. And then after realizing that it wasn't being used, which we'll see in a second, my goal was to understand which function form of flash attention or from flash attention is being used, flash attention func or flash attention varlen func. And as I dug deeper, I realized that which function is used is going to tell us if sequence packing is correctly implemented or not. So the rest of this video And in the rest of this notebook slash blog post, I'm going to be passing different inputs to the model's forward pass, observing what gets printed out based on the print statements that I put in, and then calculating the loss function or the loss value using the model's loss function to understand what are the quote unquote correct values and what are the incorrect values. So Claude gave me some fake data, and here we have input IDs where we have some random integers. So I set the seed, and then it's passing qseqlens, which is basically saying that the first sequence is 3 items, and then the second sequence is 7 items. So I think max seqlen in this case should actually be 7, not 10. But I'm gonna keep plugging away at this. And actually now that I look at this, maybe that's something that I should play around with well. So if we have time at the end of this, and if I can do it live, we'll play around with that. So if I look at my test params, here are the input IDs. We have 7685138 and it's fake data, so we're saying like this is the first sequence and this is the second sequence, but we're not explicitly giving it position IDs. That's a key thing that I want to highlight. So when I do the forward pass, I get this printed out for every single layers. So there's 30 layers. So every one of the 30 layers forward pass for the attention mechanism prints this out. So what do I see? First, I see in flash attention forward, the keyword arguments are position IDs, output attentions, use cache, qseqlens, and max seqlen. And then in underscore flash attention forward, I have these 4 keyword arguments. Attention mask is none, and the position IDs, even though I didn't pass them in, are not none. They are a sequence from 0 to 9. And flash attention func is called, and here are the flash attention keyword arguments that it receives. So if we go back here and we go inside dunder, or not really dunder, but underscore flash attention forward, we can see that, let's see. So here's where it prints out attention mask and position IDs. And then if we scroll down here, flash attention function is called, and flash attention func is called with these values. And if we look at flash attention func, none of these values are related to qseqlens. So my understanding is that this is the vanilla flash attention, meaning that it's not handling packed sequences. So this was the first sign to me that, okay, something's wrong with how I was handling my inputs. I need to give it position IDs. If you look at the model's forward pass, so if you do inspect.getSource model.model.forward, you'll see that position IDs, if it's none, which it is in my case, it will be constructed based on cache position, which is its own definition, which is based on a couple other things. So I didn't go into depth on that, but basically this is why position IDs gets generated from 0 to 9, even though I didn't pass it explicitly. But main thing here is that even though I pass qseqlens, it does not kick in flash attention for sequence packing. So second attempt, let's actually pass in the position IDs. And this is where this line here, 398, prepare FA2 from position IDs. And this is where it gives back qseqlens. And this entire code block kicks in if position IDs is not none. So if position IDs is defined, and if max length q is not none, or this condition here. So max length q, if we go to the input arguments, max length q by default is none, and I don't pass in max length q, so max length q is none. But what's not none, or what's not false, or sorry, what's not false, so true, so this is if and not this value here. So what is going on with this torch diff position IDs dim equals -1 greater than 0? So in this iteration, I'm going to construct my position IDs, and I'm going to construct them correctly because I'm following my cumulative sequence lengths. sequence lengths, where my first sequence is these 3 values here, and let me see. Let me actually, well, that's fine. I'll go through this. I might have to edit some code at the end of this notebook, but that's fine. Anyways, we have input IDs, and what I'm basically saying is this is my first sequence, and this is my second sequence. So here are the position IDs for my first sequence, 0, 1, 2, and then we start with 0 again because our second sequence is going 0, 1, 2, 3, 4, 5, 6. So I have 2 sequences packed together, and the position IDs are indicating that. So if I do this torch diff, what this is basically saying is if we look at the difference between consecutive items, so 0 and 1, the difference is 1, 1 and 2, the difference is 1, or here we go, 0 and 1, 1 and 2, 2 and 0, the difference is negative 2. So is every value of this torch.diff greater than or equal to 0? No, it's not. We have one value where it's negative because we are resetting the position ID to 0. So this call ends up being false, and not false is true, and position IDs is not none, so this code block kicks in. So what happens now? So I'm going to actually switch back to my manual seed, and I'm going to switch back to my random integers that I make from 1 to 10. And so here we have my input IDs 768, 513, 8653. Here we have position IDs 0, 1, 2, and 0 through 6. So this is my first position, 768, and this is my second position, 513, 8653. So I'm copying the same values as I did before. So up here, I actually did not end up using this. So I'm using the same integers as before. And then I have the same qseq_lens as before, and now my max seq_len is 7, which is, if I go here, max length q is not the same thing. Yeah. So when I run this, and then I pass it through the model's forward pass, this is the printouts that I get. So I have the same keyword arguments received. Attention mask is none, and my position IDs are correct, right? So here's position 1, here's position 2. And then these print statements inside here, they kick in. So position IDs is not none, and max length q check. qseq_lens q is none, and qseq_lens k is also none. So this code block kicks in because these two values are none. And then when I look at the qseq_lens that comes from prepare FA2 from position IDs, it actually is a tuple where it's 0, 3, 10 and 0, 3, 10. So the key thing is that the model doesn't actually use qseq_lens that I've passed here. It does, pass it on as a keyword argument, but it actually uses just the position IDs to calculate qseq_lens. And that qseq_lens is a tuple, which then gets deconstructed into qseq_lens q and qseq_lens k. So my main takeaway from this is that flash attention will not handle sequence packing correctly unless you pass in position IDs. So that's the main takeaway I'm getting from here. And maybe there is a way, like now that I'm looking at this up here, like maybe I should have passed qseq_lens. I don't know. Maybe what does that do? And if we run this, I mean it does have qseq_lens, but it's still using that code block where it constructs qseq_lens from the position IDs. So I don't think that was the issue. I don't think it was a mistyped value issue. But if you're more familiar with sequence packing and flash attention, you can point that out in the comment below. Okay, so let's now do two things. Let's calculate the packed sequence loss, and then let's calculate the padded batch sequence loss, and then I'll also calculate the loss if I don't pass in position IDs. So packed sequence loss is now using this output logits where I did pass in position IDs, and it was kicking in here with QSeek lens. And that means that if we look down here, it was calling flash attention varlen func. So if we look at that loss, I'm going to skip ahead to the loss. That's 20.2832. One key thing is that now that we have two sequences in our packed sequence, the labels have to be constructed in a certain way. And so I'm taking this from Hugging Face's data collator with flattening, where what I'm doing is that the first token gets replaced by -100. And the reason for doing that is that Hugging Face's loss is actually going to do the shifting of labels by one to the left. And so we want a -100 for the first token of the second sequence because we don't want the last token of our first sequence to predict anything, right? So it's essentially another way of kind of adding a end of sequence token, but we're doing it in our labels. So if we look at the shifted labels, it's just this over here, and then we have a -100 at the end because the last token of the first sequence should not be predicting anything, just like the last token, last token of the second sequence should not be predicting anything, just like the last token of the first sequence should not be predicting anything. So this way we contain information and there's no kind of leakage of information from the first sequence to the second sequence. After that point, it's pretty straightforward. We use f.cross entropy and we can get 20.2832, or we can call the model's loss function and pass it the unshifted labels because it does the shifting, and we can get 20.2832. So this is our kind of correct target loss that we're looking at. So what I'm going to do in the next block of code is I'm going to grab the input IDs, I'm going to grab my QSeek lens, and I'm going to grab or construct sequence boundaries. And then using sequence boundaries, which are just these indices, right, 0 to 3, and then 3 to 10, I'm going to construct my two sequences, 768 and then 5138653. Because the first sequence only has 3 items and the second sequence has 7, I have to pad the first sequence so that I can then stack the two and create my batch. And then I got to do the same thing for labels. I have padding tokens, so those are meant to be ignored in the loss function. So I have -100s. And then I can stack my sequences to get my padded labels. I get the logits by passing the padded batch into the model. And here we can see that this is vanilla flash attention. There's no sequence packing. And for vanilla flash attention func is called, not varlen. So this is like another check that flash attention func is indeed the vanilla implementation. So if we are expecting sequence packing to be correctly implemented, this one should not be called. But in this case, it's a padded batch, so this is the correct call. Let's compare the sequence packed output logit shape, which is 1 by 10 by vocab size. The padded output logit shape is 2 by 7 by vocab size. If we look at the first 3 logit vectors in our sequence packed output, it's the same as our first 3 vectors of our padded output. And then the last 7 vectors of our sequence packed output are the same as the second item in our padded output, which is our second sequence. So this is just to show that sequence packing does not change the output logits. It just rearranges them. And then when we calculate padded loss, so we pass it our padded output logits and our padded labels, we get the same as our sequence pack loss. So again, this shows that sequence packing does not alter the loss value. Now, what happens if I don't pass in position IDs? So this is going back to our torch manual seed 42. I have the same sequence being passed. I give it QSeek lens and I give it max seek length, but I'm not giving it position IDs. And this time, when I run this forward pass, it's going to print out that function where it says flash attention func is used. So let me see if I can rerun that. And if we run this, we can see flash attention func is called and our position IDs are defaulted to consecutive integers. So we can see that this is not going to work, even though we have qseq lens and maybe the underscore added here would make a difference, but it does not make a difference. We still have our vanilla flash attention func called. So this leads me to believe that you have to have position IDs if you want to have sequence packing correctly handled in the flash attention implementation. So if we look at our sequence pack logits and compare them to our non-sequence pack logits, even though we're passing qseq lens, the mean is 0.3, so they are different. And if we calculate the loss, this is 17.4632, whereas earlier it was 20.2832. So the loss is not the same. So that's my initial exploration here. I'll reiterate that I'm not familiar with how sequence packing is implemented in Hugging Face or Modern BERT. So that's still on my list, and I'm even less familiar with how flash attention is implemented. But I think it's an important exploration because I can see that if I don't pass position IDs, it's not going to correctly calculate the logits or the loss. So that's my key takeaway. I'll be hopefully doing more videos in this series for sequence packing / flash attention too. So keep an eye out for that. Thanks for watching, and I'll see you next time.